Consider the following processes with the arrival time and the length of the CPU burst given in milliseconds. The scheduling algorithm used is preemptive shortest remaining time first. So we have these processes, the arrival time and the burst times. The average turnaround time of the processes is dash milliseconds. So this is a question from operating systems regarding process scheduling. So here we are using preemptive shortest remaining time first scheduling algorithm. To learn about various process scheduling algorithms more, please refer to the video lectures coming from operating systems section. Okay, so here we are using preemptive shortest remaining time first, which means that we have a set of process running, and at that time if some new process comes with which has a shortest remaining time, shorter than the one which is currently running, then the one currently running will be preempted and the new one will be scheduled, since that will be having a shorter remaining time. So let's take a look at these processes and how it proceeds. So at time 0 we only have the process P1 here. So initially P1 will start running. So P1 will run from 0 to 3. Okay, at that time process P2 arrives. Now P1 has run for 3 bursts and it total had a 10 burst time. So there is remaining 7 milliseconds for process P1. But P2, when it arrives at time 3, it only has remaining 6 milliseconds. So P2 will have a shorter remaining time. So P1 will be preempted and P2 will be assigned the processor. So at time 3, P2 will start running. Now P2 proceeds, and when the time is 7, process P3 also arrives. And so at this point P2 has run from 3 to 7, meaning it has used up 4 milliseconds out of its burst time, and there was a total of 6 milliseconds, so the remaining burst time is 2 milliseconds. But now P3 also has arrived and P3 has only one remaining time, only 1 millisecond remaining time, meaning at this point P2 will also be exempted and P3 will be allotted the processor. So at time 7 P3 starts running. Now P3 has only 1 millisecond, so at time 8 P3 will be over. At time 8 P4 also arrives, but it has 3 milliseconds burst time, and we know P2 only has 2 milliseconds remaining time at this point. So P4 won't be running, instead P2 will be running at this point. So P2 runs from 8 to 10. At that point P2 will also be over, and at this point we have P1 and P4. P1 has 7 milliseconds remaining, P4 has only 3 milliseconds remaining, so P4 will be allotted the processor. So at time 10 P4 starts running till time 13, and at time 13 P4 will be over. We only have process P1 left, it has 7 milliseconds left, so from 13 to 20 P1 will be running. So now we need to calculate the turnaround time. The turnaround time is the amount of time it took till the process got over, starting from when the process arrived. So if you see, P1 arrived at time 0 and it got finished at time 20, so the total time taken is 20 minus 0, that is 20. Similarly, P2 ran from 3 to 10, meaning turnaround time is 7. P3 ran from 7 to 8, so the turnaround time is 1. P4 ran from 8 to 13, so the turnaround time is 5. So the average turnaround time is 20 plus 7 plus 1 plus 5 by 4, that is 8.25.